Good morning, everyone. This is a bit unusual, doing a Saturday morning live here on the channel. Normally I do them in the evening, but doing something fun this morning, just setting up this new CATL battery, and so I thought I would jump on here, jump on the live and get this all up and running. So probably won't chat much, although I might just talk through what I'm doing here while I'm doing it type thing. But yeah, otherwise, if anyone has any questions, then pop them into the chat and I'll try and catch it as I work through this. So just get a... so I built this little platform that the battery... So the battery is obviously in this case that I made out of plywood. And I built this platform over here, which is going to go into my camper. So I already have a really good battery in my camper, but decided I would wanted to try out these cells. I've been capacity testing them over the last week or so, and they came out really good. I'm really pleased with the performance of the cells, and so I wanted to just get them into my camper van and then use them over the summer in a real world test. And the way that I'm wiring them in, I can cut over between my existing battery and this new one once it's in there. So I give it a kind of real world test, put it through a few many cycles because I have solar set up in the camper, and yeah, we're going to see how they do. So I'm just going to secure the cells down just using these little angle plastic bracket things. So I'm going to put a couple of screws into there and secure it down with those. Alright, I'm going to use these. I bought these new stainless screws on Amazon this week. So I quite like using stainless for this sort of thing just because it obviously doesn't rust. Not that you get much moisture in this, but that angle is quite awkward. No questions yet. Is everyone awake? What time is it on a Saturday? 10:30 in the UK. Obviously, everyone in the US that watches this channel is going to be well asleep, you imagine. But yeah, we're going to get after this here. Okay, looking good. Yes, we're going to be posting videos of the testing we've done with these cells this week on our YouTube channel. So if anyone's interested in seeing how the cells performed in our test, then head over to YouTube and hit the subscribe button. We'll be putting the videos out in the next couple of weeks. They're just going to take a little while to actually edit, just because it's quite a long-winded process testing battery cells like this. So okay. If anyone has any questions for me while I'm doing this, then just pop it in the chat. I'm going to be giving away an item of our merch to whoever has the best question. So Alright, that's the cells nice and secure on there. Okay, next up, what are we going to do here? I think next I will put this fuse holder on here and run the cable that will connect to our positive terminal on the battery. So the idea with this platform is that I'm going to drop it into a slot that we have a bit of space in our electrical locker in our camper. And so I'll do that later today probably. Okay, let's get this fuse holder nice and straight. You know what, I'm actually going to change the screw that I'm using for that, just because the holes on these fuse holders are quite big, and so the little screws that I was using will probably pop through that. So I'm going to get some that are a little bit more substantial. Does anyone else put screws in your mouth when you're working like this? I've been doing it for years and I've never even come close to swallowing a screw, but it is certainly a concern, because that would suck. Alright. Getting warm in this garage now. Okay, we are going to take this cable here, which is very substantial. In US measurement, it's 1/0 wire gauge. Here in the UK, it is 50 millimeters squared. So we're going to go about there. Let's get this thing right here. No, it says on the side there. I just recently got this wire stripper, because for years I've just been using a Stanley knife or a Swiss Army knife, and to be honest I think it's probably actually easier. Do I support? No idea who he is. Somebody asking if I support somebody on TikTok. I have no idea who that is, so can't say yay or nay, sorry. Let me know who he is. Who's Levi? There we go. Obviously, it's very important not to take care when you're cutting a cable like that with a Stanley or something. Okay. Ugh. Now, what are we looking for here? 50 to 6. So we've got 50 millimeter squared cable, or 1/0, and we're going to be putting one of these little lugs on here, because that's going to fit onto the terminal on our battery. And so I'd like to put the lug in there, push it in as far as it'll go, and then I use one of these hydraulic hand crimping tools, which you really need like three arms to be able to use one of these effectively. But you can make do. You kind of get used to it. The trick is to not get your finger caught in the teeth, because I don't know, I can't remember how many foot-pounds of pressure you can get on this thing, but it's a lot, and you certainly don't want your fingers caught in that little thing. So I like to put this index finger on the top of the jaws there, so that I have some leverage, and then with this hand, my left hand, I'm pushing the cable into the lug so that it goes in as far as it'll go, and then I rest the bottom of it onto the workbench and keep compressing until I can't compress anymore, and then I release it just with that little dial on the side there. And then I actually go and I do it a couple of times along the shaft of the lug, just because then you get the cable well, try and get as much of a cold weld there as possible. Oops. And I'll do it all the way up to the end of the lug, right against the insulation on the cable. Okay, this thing's twisted here a bit. Alright, release that, and there we go. You look at that. That is a nice crimp on there. Give it a bit of a tug test, and I'm pretty happy with that crimp. So that's what you'd call a cold weld. And then I always like, because these are non-insulated lugs, I always like to put heat shrink on here, and I always go for the heat shrink that has the adhesive built in. Put my heat gun here. And I just go until you can see the adhesive starting to come out the top and bottom of the heat shrink. It's kind of when you know it's done enough. Don't touch that just yet, because that'll be pretty warm. So we'll just leave that off to the side to cool off, and then while it's cooling, I'm going to take this. I've been doing some capacity testing on this battery, so I'm just going to take the positive nut off, and I'm going to unplug my balance leads from the BMS just while I'm doing this. Take that positive nut off, hold the cable off to one side. Okay, this cable that we've just crimped is cool enough to pass through, so I'm going to put it through the little hole here that I made. Oh, a bit of a squeeze. And then put the balance lug back on there and get the nut down. And then I'm using a little torque wrench. What am I doing? I'm assembling, getting a lithium iron phosphate prismatic battery ready that's going to go into my camper van later today. So I'm just connecting it to a fuse block and a couple of breaker kill switches and things like that. So I'm torquing this nut to 9 Newton meters, so that's what the manufacturer of these prismatic cells has recommended as the maximum torque rating that you can put on these welded studs, which is quite a lot when you consider they're only 6mm welded studs. But that's one of the reasons why I like these welded studs more than the alternatives, which are threaded holes in your terminals, because you can get much better torque settings on these than on threaded holes. So I'm going to put my balance leads back into my BMS, and I've got a little on switch here. Just push that on switch, and then I'm going to double check that my BMS has turned back on. So I'm going to put this red probe on that terminal, and that's I've got 11.4 volts, which is what I would expect. So the battery is not fully charged; it's actually completely depleted because I have been running some capacity tests on it. So it is what I would expect. So let's see here. I'm going to run this cable around like that, and then down, and then onto my fuse block there. So let's see, the length of cable I'm going to measure, and it's going to be, don't want it too long because I don't want it sticking out the back of the battery too much. I'll probably take it about there. This cable cutter is super handy if you're ever cutting sort of really thick cables like this. I only learnt about this in the last few years since I've been working with these really thick cables a lot. But it's like a ratchet cutting tool. So before I used to use all sorts of side cutters and hacksaws and all sorts, but this makes it so much easier and quicker to cut these thick cables. When you have such a lot of copper in these cables, they are quite difficult to cut unless you have a decent method like that, but that makes short work of it. Super easy. So I'm doing this the clandestine way again with the old trusty Stanley. So probably not recommended, but watch your fingers if you do it that way. Alright, and then always make sure I always work with a selection of connector lugs like that, all uninsulated because I insulate them myself, but just so you can get the right size. So I know that this fuse block uses an 8mm, and so the other thing that's handy when you're working with such thick cable like this is to put your cable kind of in place of where it's going to go before you put your lug on, so that you can make sure that you get the orientation of your lug correct, because this cable is quite difficult to maneuver and move around and stuff, so it's very handy to be able to put it the right way around so that you don't have to twist the cable weirdly. And then we go through, where are you all at? I live in Northern Ireland. Okay, let's twist this back around. And let's see, we're going to get this through here, yep. Okay, and let's crimp it. Okay, again, same sort of thing, index finger over the claws, hold the cable with the rest of your left hand to be able to push it in as far as it'll go, and then you clamp this down as far as you can, kind of resting it on the table like that, and then I like to go and hold it like you're supposed to and clamp it as far as it'll go. Once you feel those two teeth, the claws make contact, you can kind of sense, with a bit of experience, you can then tell when you get a good cold weld, which is essentially where you've compressed the copper as far as it'll possibly go, and that is as good as you can get outside of using a proper machine hydraulic crimping tool. A lot of people actually, especially in modern times where a lot of solder or solder, if you're in America, is not lead based. A lot of people would argue that a cold weld like this is better than if you were to solder it without with modern soldering, with modern solder, because modern solder is not lead based, it's more of an alloy, so it doesn't conduct as well as the old-fashioned lead solder. Okay, I've got a bit of the lug that's sticking out the bottom there, which will cut through the heat shrink when I go to put that on. So I'm just going to fold that over, make it nice and neat. And yeah, I'm really pleased with this new, I just got this new crimping tool recently, so I'm quite pleased with that. Okay, let that cool down for a second there, and then we can connect it up here. Just going to grab some things to hold the cable in place. Just one sec. Forgot to get these out earlier. So you like to use these little plastic cable holders. So once I've got the cable onto my fuse holder down here, I'll just attach the cable to the side of my battery case using those. So now that we've got that terminal and the heat shrink cool down nicely, I'm gonna just loosely connect the cable onto the fuse block there, and then we will secure the cable on the side of this case here. So I'll probably do a couple of these things on the side here, just to hold the cable nice and securely. Something like that, I think. Let's use these little stainless screws again, and the old DeWalt. Okay, that'll work nicely there. Almost don't need a second one in here, but I'll put it in just for good measure anyway. Sweet. Alright, pleased with that. Actually could do the third one there. I'm going to put a third one in here. Sweet. Perfect. Okay, so that's the positive to that. Now I'm going to use, got this little guy here, which is from something that previous install, which is actually the perfect length for that first kill switch. So I'm just going to use this rather than making another one, just repurpose it. Okay, and then these kill switches have a 10mm bolt on the bottom, so I need to find a different one now. That's the trouble with all this sort of stuff, is often you have like multiple size bolts and things that you need to be able to cater for. And again, you're just checking that you orient this thing the right way around for where you're putting it, and we will go again. Somebody asking what this is for. So this is a battery that I'm going to be putting in my camper van. So I've been testing this battery over the last few days, and super pleased with how it's performed. So I'm just doing the final assembly now here on my workbench before I actually go to install it. Probably this evening I think I'll install it. Need a bigger workbench. So somebody asking what am I going to run off this one battery? Believe it or not, this battery is capable of a lot. It has the same capacity pretty much as about 3 or 4 conventional lead acid batteries. So like the sort of more other batteries that you would get in a sort of car auto parts shop like Halfords or something like that. This battery is the same capacity as about 3 or 4 batteries like that, so it's very high, a lot of capability, and so on this battery I'll run everything in my camper van that I need to run. So it'll run all of the lights, USB ports to charge phones, tablets, all that stuff. I have a 12-volt charger that I run my laptop on in the camper, so it'll run that no problem. And I also have an inverter, so if I ever need to charge anything that I can't run on 12 volts, so if I just have a conventional plug that would plug into the wall at home or something, it'll run that as well. And that inverter is quite a high capacity inverter, so I could even run a coffee machine. So if I wanted to, I could run something like an espresso coffee machine, or even a microwave. Not that I use a microwave, but if I wanted to, I could run a microwave in there. Somebody asking what van I've got. So I use a Euromobile van is what we use. It's based on a Fiat Ducato chassis, but I'm also in the process of building out a new van conversion on a Nissan MV400 chassis. 1200. No, my converter is a 2 kilowatt inverter. So you can have a constant output of 2 kilowatts from the inverter, or peak 4 kilowatts. So it's quite a substantial inverter even. This stuff is so time consuming when you start getting into it. You can spend literally hours building out these things. Okay, I'm very happy with the crimp on that one. Good cold weld on that. Kind of goes without saying, but if anyone ever uses one of those heat guns, they get very hot on the tip, so don't be touching your hand or something with one of those things once you've had it running for a little while because it will burn you bad. Asking how many amps can you pull. So this inverter, I can pull 200 amps from it in 12 volt. So, and it's mainly, I mean, the cells themselves do have some constraints as to what they can, what they will reasonably, what you can reasonably pull from them. But yeah, the main constraint here is down to the inverter, sorry, the BMS, so this red thing that's attached to it here. So that is a 200 amp BMS. But to be honest, most people, unless you have like a cabin or somewhere that you're pulling substantial power from your battery system, most people are not going to pull more than 200 amps from their battery, especially in a van or an RV or that sort of setting. Because I mean 200 amps is substantial. So on my 2 kilowatt inverter in my van, if I max that inverter out, it would be like 180 amps or thereabouts. So okay, so this little kill switch is going to go here. So these things are a bit of a pain because you have to, especially when you're working with such thick cables, just some advice for people is I find it easiest to put your cables on and then all loose and then tighten it all down, just so you get the measurements right and all that sort of stuff, because they are a bit of a pain to connect and to get straight and stuff. Have you got 500 watts? So I've got 550 watts of solar on my van. And so running a 200 amp hour battery, the big thing is in Northern Ireland, and a lot of the UK and Northern Europe is very similar, because we have such big change in daylight hours throughout the year. So going from summer to winter, so like here in Ireland, for example, in winter, peak winter, the shortest days of the year, you get an average of just under 2 hours of usable sunlight in the winter. So in the middle of, like, say, December, for example. Whereas in the summer, you're getting an average of like between 9 and 10 hours of usable sunlight. So our summers we get more higher average hours of usable sunlight than some places in like California. So it's just useful to know when you're building out a rig or a van or something, just because the usable sunlight is very important for solar. So in winter you get very not great use out of solar over here. Yeah, so I mean, over here you're having a way of charging your batteries from your engine is very important. So I like to use a battery to battery charger or DC to DC charger. That's my preference. Mainly because with this particular chemistry of battery, so lithium iron phosphate, you can't actually just charge it straight from your engine battery. You need to have a battery to battery charger to be able to charge it, because it's slightly different voltages to your inverters, and split charge systems are just not great for lithium iron phosphate. Okay, so one thing with using these thick cables like this is bending them around stuff is a bit of a pain. Okay, so let's see here. We're going to do this one like that. I find the easiest way to install these kill switches with such substantial cables like these 1/0 or 50mm squared, is to prepare your cables before you attach the kill switch down, tighten everything up, and then fix it down. But yeah, if you I would definitely recommend a DC to DC charger instead of split charge, unless the only time that split charges is much good is if you have the same chemistry between your engine battery and your leisure battery or your house battery. But even then, the age of your battery, so if your engine battery and your leisure or house battery are different ages, that can have an impact on the charging and how it all works, and how well it works together and stuff like that. So there's a lot to be said about split charge systems and B2B chargers. So that's why I always recommend to people, if you have the budget, then get a DC to DC charger, because it's a much more efficient way of charging your house battery. So like in our camper, I put in a 90 amp DC to DC charger, so we charge our house battery when we're driving very fast with 90 amps, and I had to change the alternator on the van to be able to cope with that amperage. So obviously that's another expense, but at least I know if we drive for a couple of hours, it's going to pretty much charge that battery, 200 amp battery in 2 hours charging at 90 amps. It's going to pretty much charge it from flat in 2 hours. So what time are we on? How long have we been on here? 38 minutes. Wow. I was like, I keep seeing this number on my computer, which is just next to the phone there. And it says 5:36 currently. And I thought that was the actual time. I was like, not possible. It's been longer than 5:36. But that's the average, some average number. What makes so I use a DC to DC charger called a Virtronic, which is made by a German company called Virtronic, and we've used their equipment for years. So we've been using their chargers on and off for a long time on various rigs and systems. So I'm a big fan. So that it has quite a lot of I mean, it doesn't have some of the functionality that you get like in Victron, are probably one of the most popular. However, I'm not a huge fan of Victron because there's certain things that they are quite behind on. So for example, Victron doesn't trickle charge your engine battery from your leisure battery, and things like that, whereas Virtronic have been doing that for years. And so it's not a huge deal. Most people don't care that Victron don't do that, but it is handy if you ever leave your van unattended for any length of time. So like especially in these lockdowns recently and stuff like that, it's been handy to know. And also if you just happen to leave something on in your cab or something like that, if you have good solar like I do, I know that I can leave my van for as long as I want pretty much, and it'll still keep the engine battery topped up through the DC to DC charger. So Victron don't do that, whereas Virtronic do. So there's little things like that where I really like Virtronic from that point of view. And to be honest, with these batteries that we're building, like this one here, the BMS that we install has Bluetooth capability. So we connect to this battery with our phones and just watch what it's doing, see what the state of charge is, check the if it's charging or if there's a draw on it. We can check that. So I don't think that having a Bluetooth capability on your actual charger is that important these days. So these are the two this cable here I'm going to cut in half once I get it onto my van. So I'm just going to leave it one big piece and then connect it each end into these circuit breaker kill switches. Yeah, so the Virtronics, I think they started, yeah, probably around £200, £250, somewhere like that. If you get like the top models, as in like in terms of capacity. So I think my one was like £350 or somewhere around there. So it is quite a lot of money, especially when you can get a split charge for probably, I don't know, £20 or something like that for a decent, reputable make. But again, it goes back to just what you do and also what chemistry you're running in your van. So if you're running lithium, then you pretty much can't do a split charge system. But if you have lead acid, then you can get away with it. But again, it just goes back to how you want it to perform as well, because a DC to DC charger is going to perform much better than a split charge system, because a split charge system is just going to pump in whatever voltage you're getting from your alternator and some sort of amperage, but it's not going to be consistent because it'll depend on what you're drawing from your engine battery and the voltage of your engine battery and the capacity of your alternator, and all that sort of stuff will factor into how much charge your leisure or your house battery gets. But whereas with a DC to DC charger, you will get a consistent amperage and voltage, and it'll adjust that depending on what the state of charge is of your leisure or your house battery as well. So yeah, there's loads of benefits to having a DC to DC charger. All right, I'm going to take this off because it is getting hot in this workshop now. Alright, and the home stretch here. How long have we been going? 45 minutes. that. Things get hot when you put them on the old heat gun. So I'm putting 2 kill switches on this battery, as in these circuit breaker cutoffs. Mainly because I like to be able to control the charge and the load separately. So it's not essential, but I just like, that's the way I like to do it. Something very satisfying when you're doing electrical work like this, building out a battery or a van or something, and making it look really neat and tidy and looking good. Started out quite gloomy and cold this morning here in Northern Ireland, and it's really picked up now. It's looking good out here. Okay, let's see. Let's get this all up here. These thick cables are quite cumbersome to maneuver sometimes. Alright, I think we're somewhere now. Okay, now is the fun bit. We can screw these down. Okay, that. Find the right size screw to be able to use on these. These ones will probably work. Quite big actually. Sweet. Alright, let's get this thing down on here. What size is this? 15 more probably. Okay. Let's Okay, I'm going to put one screw in here and then just straighten this thing out before I put the second one in. happy with that. And we'll just okay, come around this side to do this other one. Actually use this drill properly and not have it on drill mode. I'm going to have to do those two by hand, I think. The old-fashioned way. Just because I can't get the drill past the BMS there. Okay, last one, and then that should be our positive line done. Okay, that's good. You can easily turn these off and on. That's pleased with that. Just going to tighten down this fuse holder here. Okay, it's looking good. And then lastly, we're going to put a bus bar over here for the negative line. So we've got our negative coming off the BMS here. We're just going to very simply put a bus bar here that it can attach to, so we don't have it just flailing around loose. This is another one for the old-fashioned screwdriver. Okay, that is secure. Now we're just going to tighten the BMS on the bus bar there. Happy with that. I think that's us. Ready to go. So this is obviously just all one long cable there. Just each end just goes to each of these circuit breaker kill switches. So I'll just cut that at the appropriate length when I put it into my van, and put a lug onto each of those, and then put it onto the correct line in there. Got those fastened down nicely. Got a bus bar for the negative. BMS is securely fitted. Battery itself is secured inside there. Everything's neat and tidy here. Got my fuse in here. Everything's tightened down on that. So yeah, pretty pleased with that. It's probably about, let's say, 18 kgs, 15 kgs maybe. Not quite, maybe 15 kgs I'd say. So yeah, in terms of, when you consider this is actually lighter than a lead acid battery, and can probably do like 3 times the capacity of a lead acid battery, I'm pretty pleased with how it's turned out. So yeah, I'm going to call it there and end the live here, guys. Thanks for watching. As I mentioned before, I'm putting up a review of these cells on our YouTube in the next couple of weeks, and also another video with the results and the walkthrough of our capacity testing. So if you're interested in that, then make sure you subscribe to our YouTube channel so you can see those. And also, I made a fairly in-depth video of actually building this battery out, so what I did sort of step by step. So if you're interested in seeing how we actually build out these custom batteries, then that'll be on YouTube as well. But yeah, thanks for watching, everybody, and tuning in. I hope you have a good Saturday and have a good weekend. Cheers.